Hello class, this is the second part of section 4.1 video, and in this video we will look at two things: the end behavior of the graph of a function, a polynomial function, and then also we will graph polynomial functions using the x-intercepts, which is the last learning objective for this section. Okay, so the end behavior of the graph of a polynomial function. Say you have the standard of polynomial function an xn all the way where an is not equal to 0. Okay, now the end behavior will behave just like what? The leading term. Okay, now this leading term, note that this is a power function. Okay, it's a power function as we talked about in the previous video and then also in class. So if the power function, what is happening is that if x, the n, okay, if it is even, if n is even, what happens? And then if n is what? Is odd, okay, what happens to the behavior of what? Of the function? All right, so we know that if n is even, then this power function or this leading term, okay, becomes is a even function which is symmetric with respect to y-axis. If it is odd, it is symmetric with respect to what? The origin. All right, so from this theorem we have the following what? Possible end behavior of what? The graphs of the polynomial of a polynomial function. Okay, so if you look at the first video here, the first graph, which is the graph A. Now this is for when the n is what? It's even, and it is what? Your an, it depends on the an. If an is positive, okay, if that's just like a quadratic function, it opens upwards if a is what? Is positive. So the same way, this graph, the n will behave this way. It's going to rise to the right and to also rise to what? To the left, okay, as x goes toward positive infinity and then negative infinity. On the other hand, if the an, that is for this function, this is this part, that is an x to the n. If your an is negative, then the opposite of a happens. The graph A happens. In other words, as x goes to positive infinity, negative infinity, the a function falls to what? To the left, and also if as s goes to positive infinity, it falls to the right. Okay. On the other hand, when you consider the odd, when the n is a positive integer greater than or equal to 3 and is odd, and your an is positive, it's going to rise to the right and it's going to fall to the left as s goes to positive infinity and negative infinity respectively. And then lastly, if your an for where n is odd, okay, the degree is odd, and the an, that is the leading coefficient, is negative, then the opposite of what? The graph of C happens, which means that as x goes to positive infinity, the function falls to the what? To the right, and then it rises to the left as s goes to what? Negative infinity. Okay, so here is an example. We are given a polynomial graph of a polynomial function, and they want us to find the polynomial function there. Okay, so we want to start with what are the factors? Okay, the factors comes from the what? The zeros of what? Of the function. Okay, so we know that x, the zeros are what? X equal to -1, s equal to 1, and the s equal to what? S equal to 2. Okay, so what are the factors? You will notice that if x is equal to s is equal to -1, the factor is what? X plus what? Plus 1. And then for x equal to 1, the factor is x minus 1. And then for x equal to 2, the factor is what? X minus what? Minus 2. But something happens in terms of, we'll talk about it in terms of its multiplicity. Okay, so the question is that part B, what is the degree of this function? All right, we know the turning points. We know the turning points. All right, how many turning points are there? There are 3 of them. So it means that, how do you find a turning point? We know that it's n minus 1 is the function, a polynomial function will have what at most, or the maximum number of what turning points will be n minus 1. So if we have the 3 turning points, there's 1, 2, and 3 here, then what is your n? Your n is, in this case, will be what? 3 plus 1. So the degree of this function, of degree of f, is what? At least what? At least 4. So that means your n, it can be greater than equal to what? Equal to 4. And here we'll pick the least, or the smallest degree, which in this case will be what? Will be n equal to what? Equal to 4. All right. So now let's talk about the multiplicities. Now here are our factors. Okay, our factors are x plus 1. Okay, and then the other one is x minus 1. And then the other one is x minus what? Minus 2. In terms of multiplicity, because the graph touches the x at what? Negative 1, the multiplicity of that is an even function. Okay, so the multiplicity of this, we use what? We use m for that. This will be, it will be what? Will be at least 2. Okay, so it could be 2, 4, or 6, because it's even. It must be even. All right. Now it crosses the what? It crosses the x-axis at what? At 1, and also at what? At 2. So for that, it's an odd function. Sorry, it's an odd number. So the multiplicity, okay, your m must be what? 1 or 2, sorry, or 3 or 5, and so on. So we'll pick the least, which will be m is equal to what? Is equal to 1. And then similarly, because it crosses the graph at what? Positive 2, the multiplicity of what? The factor x minus 2 is what? The least of that will be what? Will be equal to 1. Okay, so with this, we should be able to what? Write a function. And then the thing we need to do is what? To find the what? The leading coefficient. Just as we did in the case of quadratic functions in chapter 3. All right. So it says that we need to determine, okay, we need to determine the leading coefficient, using the smallest degree possible, which will be what? Which will be 1 for odd multiplicity, and then 2 for even what? Multiplicity. So as we have explained in the previous slide, okay, the multiplicity of the factor x plus 1, the minimum is what? Is 2. The multiplicity for x minus 1, the factor, the minimum is what? Will be 1. But this also could be 3, 5, and so on and so forth. So this is also, we are using 1, and here we are also going to use what? Using 1. So if I should write the function f of x before even we go there, the function of x would be what? A x plus what? X plus 1 raised to the minimum, the least of the multiplicity, which would be 2 for the factor x plus 1, and the s minus 1, that will be 1, and s minus 2. So our job is to determine the value of what? The value of what? The value of a, which in part D is that it determine the leading coefficient, which is the a, so using the smallest degree possible, 1 for odd multiplicity, and 2 for even multiplicity. And so we're going to write a function as we did. We just write it will be a, and then x plus 1 raised to what? 2 times x minus 1 raised to 1 times x minus 2 also raised to 1. Okay, so how do we find a? As I said before, how do you find a? We're going to use a point. Use a point on the graph. Use a point on the graph, which in this case we use what's the y-intercept, which is 0, 4. So when we use that, this is going to be y is what? 4. And you have a times x is 0, so 0 plus 1 squared times 0 minus 1 squared times 0 minus 2. Sorry, 0 minus 1 is not squared. Okay, so this gives us what? A times 1 squared is 1, minus 1, and then minus 2. So this gives us what? 2 or 2a equal to what? 4. And therefore your a is what? 4 over 2, which is what? Which is 2. So what is our function then? Our polynomial function f of x will be what? Will be 2 into parentheses x plus 1 raised to 2, x minus 1, and then x minus 2. Please, I want you to know that this is what? The least possible, okay? This is what? The least possible what? Possible function, polynomial. Okay, function for this graph. That's be the list. Okay, this will be the list. It could have, we could have 2 times x plus 1 all to raise to the 4 and so on, but we pick just the smallest degree possible. Okay, so that is this graph, or this example, end of that. Now we want to find, last example for this section is graphing polynomial function using x-intercepts. Using x-intercepts. Given the function f of x, which is what? X minus 1, x minus 3 raised to 2 times x plus 4. Okay, A is to find the x and y intercepts for the graph, for the function. Okay, and then use the x-intercepts to find the intervals on which the graph of f is above the x-axis and then on which is also below the x-axis. Okay, and then we'll locate other points on the graph and then we connect all the points with a smooth, continuous what? Continuous curve. Okay, so let's get going. All right. First, we have our function f of x is what? X minus 3 and then x plus what? Plus 4. So let's go back and check that. X minus 3 squared, x plus 4. That's our polynomial function. So what is the y-intercept? The y-intercept, what do? We set x to 0. So that's why we find f of 0. When f of 0 of this, what do we get? If you find f of 0, this is going to be minus 3 squared times what? Times 4. All right, and that gives us what? So get 9. 9 times 4, which will be what? Which will be 36. Okay, so the y-intercept is what? 0, 30 what? 36. Okay, then we need to find the what? The x-intercepts. What are my x-intercepts? Now for x-intercept, guess what? We have to solve the equation f of x is equal to 0. Now if f of x is equal to 0, it means that we take this whole function x minus 3 squared times x plus what? Plus 4, and we set it to what? To 0. Okay, so when you set it to 0, we find out that is using the what they call it, zero product rule. Okay, we call it zero product rule. Okay, meaning that we take x minus 3 squared, we set it to 0, or x plus 4, we set it to 0. Now if you set it to 0, they're going to square root of both sides. Square root of 0 is what? Is 0. So you have x minus 3 equals that, and that gives you x is equal to 3. And then for this one, x plus 4 equal to 0. That gives me x is equal to minus what? Minus 4. So my x-intercepts are negative 4 and then what? Positive what? Positive 3. Okay. Now what is happening is that on the x-axis, okay, we're going to have a line, and this is minus 4, and say this is what? This is 3. Now there are, divide this into what? 3 intervals where we have from negative infinity to what? Minus 4 for this interval, and then we have -4 to +3, and then we have 3 to what? Positive infinity. And so what we're going to do is that these are the interval. We're going to test them and see where it is what the function is, the graph is above or below what x-axis. So this takes us to the next, the second part of the question. It says that construct a table because we want to find where it is above. Okay, so like I described, we have your, this is your x-axis, okay, your x-axis, sorry, x-axis, and then you have -4 here. These are the intercepts, okay, and 3. Now I call these what? Key numbers. The key numbers, my own terminology from other textbooks, that's what they call it. It's what? It's your zeros, which are basically the what? The x-intercept. So your zeros are the x-intercept. The x-intercepts are your zeros. You get it? Okay. So for each what? Interval that we describe, we're going to pick a value within that and test it over what? The f of x, okay, which is x minus 3 all squared and the x plus what? X plus 4. Okay, so we do that from this table. If you consider the interval minus infinity to +3, we pick -5 as a test value, and then when you evaluate it, so if you plug -5 into the function f of x, you get -64. Now, because it's negative, the graph location will be what? Below x-axis. Okay, and so this gives me a point on the graph, -5, and then y coordinate is -464. On the other hand, if you look at the interval between -4 and 3, if I use -2, if I use 0, you can use any value within that. If I use 0, because 0 is right here, if I use 0, then I have what? Excuse me, just like the x-intercept, y-intercept, you get what? You get +36. Or in this case, if I use -2, okay, this is actually -2. All right, that gives me what? That gives me 50. Okay, so the point on the graph is what? -250, and because it's positive, it is what? Above the x-axis. And the last but not least, the interval 3 to +infinity, we use say 5. We evaluate the function at 5, and we got what? 36. All right. So when we do that, we plug it into the function. It is above the x-axis. All right. It's above the x-axis, and then we have what? -5 and 36. Okay. Now let me go back and check my. Okay, you get 9 times 4 is 36. Okay, that's fine. Okay, so that is it. Now we're going to put this together and draw the graph. All right. Okay, so we have our table. We have obtained 3 additional points. Okay, -5, -5, -64, -250, and then 5 for 36. Now within the interval, it is what? Interval -infinity to +infinity is below x-axis. The interval -4 and 3, it is above x-axis. And the interval, what do you call it? 3 to +infinity. This is +infinity, not negative. It is what? It is above what? Above the x-axis. Okay. So if I want to grab this, okay, I'm going to sketch it here, but I have it done beautifully. Okay. So we have this. Okay. This is what is going to happen here. Well, we have -4 here. Let me put -4, and then put +3 here. All right. Okay. The y-intercept is, let's say that is 36, right? It'll be 36. And then we have -2 is 50 somewhere there. All right. So that's -2. Okay. The graph crosses these points. Now, from -infinity to -4, the graph is below x-axis. So you're gonna draw The graph goes down like this. Okay, and it says that at the intercepts, we know that when x is equal to 3, the graph touches it because the multiplicity is what is 2. So it's going to touch it this way. It goes and turns somewhere. Okay, and at -2. So we have this, and it crosses that, it turns somewhere. Okay, it comes down, it's above between -4 and 3, it's above, and then between 3 and positive infinity is also what? It's also above the x-axis. So we get a graph like that. Now I'm going to erase my graph to show you a better graph, which we're using a tool to graph that is more beautiful than what I did. Okay, so this is the graph. All right, so below, as you can see, below x-axis, it is the interval from -infinity to -4. It is below the x-axis, as you can see, and then between -4 and then 3, this is 3, it is above the x-axis, and then also from 3 to positive infinity, it is above this. And then we plotted the points 5, 36. The x-intercept is, the y-intercept is also what? 0, 36, okay, which is right here. And we get this beautiful graph. So this actually brings us to the end of this video. I hope it's helpful. Let me know. Thank you. And I'll see you in class soon. Bye-bye.